Well, welcome to Chapter 6, Arrays. I hope you find this as interesting as I do. How do we solve a problem like this? We need to store all the numbers so we can go back through them and check if a number is above the average. It would be impractical to declare 100 unique variables, each with a different name. Ta-da! Arrays to the rescue. With arrays, we have one variable name that defines a list, in this case, a list of 100 numbers. In this chapter, visually think of an array as a simple list of data, and all the items in the list are the same data type. You use lists all the time. You go grocery shopping. Your list contains grocery items, all the same type. You can tell me what the third item, or element in the proper term, on your list is. You can add to your list, and you can take things off your list. We'll learn how to do all these things with programming, in this case, Java. A list is called an array. We'll be covering a lot of material in this lecture, so it'd be good to be sure to watch the other videos as well for reinforcement. You've been declaring an array from the first Java program you wrote. Do you know where or how? Well, as a formal parameter to main, you've been typing string, bracket, bracket, args, declaring an array of type string named args. Really, args is just a name. You could have just as easily named your array Lorax, but that wouldn't be very useful. We'll look at several examples from filling an array with data for accessing the elements of an array. A for loop is just a ticket for starting at the beginning of an array and inspecting or using each element in the array. I call this process walking through the array. The for each is a new loop command designed especially for walking through an array. Finally, we'll look at the API and some array methods. Well, this slide gives quite a bit of information about arrays. The red statement is declaring an array variable named myList of type double. Note, it is the square brackets after double that tells the compiler that you're declaring an array. MyList is a reference variable. That is, it contains an address or a pointer into memory where your array resides. It does not contain the array elements, only an address, a reference to where the array exists in memory. In practice, we refer to the variable name as the array. So in this case, when you tell me my list, I know you're referring to your array. However, the red just declared the array. The green coding is necessary to create the array, instantiate. It specifies the data type again and the size or number of elements the array must accommodate, in this case 10. So space is allocated in memory for 10 doubles. How much space is that? Well, refer to page 32 for the answer. Once again, the size is fixed. It cannot be changed. This is a limitation of Java. Other programming languages may allow resizing an array. The brown background is showing us how we reference an element of our array. An index number is needed. It can be a literal value as shown, or it can be an integer type variable, as we'll see later. Note that the first element is number 0 and the last element is number 9, one less than our size. If you try to access an element outside those ranges, -1 or 10, you'll not get a compiler error, but surely you'll get an out-of-bounds runtime error. Well, simply remember that an array is stored somewhere in memory, with each element of the array stored adjacent or in contiguous memory space. The above example is the preferred way to declare an array. Note the simple process of declaring a variable of any type does not create it. The variable does not exist in memory until, well, for a primitive data type, we give it a value. For example, we can declare a primitive variable age as integer, int age, but age does not exist until we give it a value, i.e. age equals 21. So many times we declare and create at the same time by initializing, and we write int age equals 0. Well, the process is a little different for reference variables such as arrays. With reference variables, we must use the new keyword to allocate memory space for our array and automatically initialize it. This process is referred to as instantiation. In the example above, MyList has been declared on the previous slide. We now use the new keyword to allocate memory for 10 values of type double. This process also initializes each value. For numeric data types, they are initialized to 0. Character, that is CHAR, are initialized to space, and Boolean are initialized to false. Note, only primitive data types are initialized when creating an array with the new keyword. Reference data types such as string are not initialized, and each element is null. Well, just as we can declare and initialize primitive data types in one step, the same is true for our array. It's important to point out the assignment equal new double 10 does not put 10 memory locations into MyList. What it does is set MyList's value to a memory address where the first element of the array can be found. What you'll come to discover is that most reference variables have properties and methods that we can use to our advantage when programming. Arrays have a length property, and we'll come to learn they have several methods as well. When accessing a reference variable's properties or methods, we use the dot notation. Reference variable name, dot, property or method name. Generally speaking, if the access does not require a set of parentheses, then it's a property. Otherwise, methods require the parentheses for access. Well, the array elements are accessed through an index, and it is the index that makes each element a unique variable. The array indices are zero-based, and indices always start at 0, and the maximum value of an index is the array's length minus 1. So in the example we've been using, MyList holds 10 double values, and its indexes are from 0 to 9. The first example demonstrates an element being set to a value, while the second example demonstrates that we can use the values of different elements in an array the same as any other variable. Well, if you know the values that you need to initialize your array to, and there's not very many of them, you can use this shorthand syntax to declare, instantiate, and initialize your array. Note, this must all be done in one statement. If you try to split the shorthand statement into two statements, you'll get a syntax error. Note also, the new keyword is not used with this syntax. The shorthand notation only saved us a few statements, and as pointed out, it's only really usable when you have a few known values that you want to initialize your array to. Let's step through a little program that will manipulate an array. The first statement here declares and instantiates an array named values. Note that since it is an integer array, each element is initialized to 0. Well, we're going to use a little for loop to place some values in our array. Note that I is used as our loop counter variable, and it's also used as an index into our array. Pause the video and see if you can determine what the value of each element will be. Well, the loop sets the value of the current element indexed by I to the sum of I and the value of the previous element indexed I minus 1. And since I starts at 1, the value of value indexed 1 will be 0 plus 1 or 1. Well, why is the loop condition set to I less than 5? Well, that's because since I is our index, the maximum legal value when using it as an index for the values array is 4. Another way to write the condition would be I less than values dot length. Remember, values dot length returns 5. We execute the loop and set the value for values indexed by 1 to 1. What will be the value of values indexed 2? The loop increments I. Our condition is tested and it's still true, so we'll execute the loop body once again. I is equal to 2, and the previous element's value is 1, so 2 plus 1 is 3. What are the remaining values going to be? 6 and 10. Execute the body again. And let's do it again. Well, now we're done with our loop, so let's move on to the next statements following the loops. At this point, remember that the variable I is no longer accessible. Its scope was the duration of the loop. Well, pages 201 through 203 have several examples of initializing array using various techniques. I'll only point out some of the techniques that are somewhat more interesting, at least more interesting to me. Note how these examples all use a for loop, and the loops use the length property to determine how many times to execute the loop body. We've used the random method several times in the past, and this little loop here initializes our myList array to a set of random integers, less than 100. A common problem you'll encounter is needing to sum all the values in an array. But once you have a sum, you can easily find the average. Let's see how in this problem we begin by setting the max to the element 0. Then we walk through the array, starting at element 1 and looking for any values larger than the max. If we find a value larger than the max in the array, we reset max to that value. Shuffling is an interesting problem, and it simply involves moving the values randomly around in our array. Note how each time through the for loop, a new random integer for our index is generated, the red code. And simply by multiplying the array's length times our random integer, we will generate a valid index. The blue code does the moving by moving the value in the array indexed by I to a temporary holding variable, and then moving the value located by our random index into the space occupied by indexed I, and then moving the temporary holding variable back into the array located by index. Take a minute and study this swapping technique. You'll be able to use the concepts when you are asked to sort an array. Well, the Java Development Kit 1.5 introduced a new loop type. It enables us to traverse the complete array sequentially without using an index. This new for loop syntax is referred to as the for each loop. It allows the programmer to sequentially move through an array element by element from the beginning to the end. And as with any loop, the body execution can be altered through the use of break, which terminates the loop unconditionally, or continue, which continues the loop but skips the following statements. In the example above, each element of my loop is displayed. As the loop processes, my value is set equal to the current element of the array. And then my value can be dealt with inside the loop body in any way needed. It should be noted that any changes to my value have no effect on the values in the array. Finally, you need to be aware that the variable used to receive the values from the array must be declared in the for each loop. In our example, double my value needs to be declared as shown. Note also that the for each loop only allows sequential, that is element after element, processing of the array, and can only be used to read the values of the array. You still must use an indexed variable if you wish to traverse the array in a different order or change the value of any of the elements in the array. Well, the video explained a lot about the LOTTO numbers program. You play the lottery regularly. Each ticket you buy has 10 unique numbers ranging from 1 to 99. And you buy a lot of tickets. So you'd like to know if the tickets you have cover all the numbers from 1 to 99. You write a little program to keep track of the numbers you have bought for this week's lottery. You'll enter the numbers from each ticket and use an array of Booleans to keep track of the numbers that you have. Remember, an array of type Boolean is initialized to false. Well, first of interest in this program is the red code. 0 is not a valid lottery number. So the while loop will continue to run until 0 is entered. Inside the loop, the is covered array element corresponding to the lottery number is set to true. Well, not exactly, since an array is 0-based. And in order to cover the lottery numbers from 1 to 99, the number entered can't be used directly because the maximum index value is 98. That is, the index values 0 through 98 provide enough storage for 99 values. Consequently, this is why 1 is subtracted from the number before we use it as an index. Now take a look at the blue code. The condition of the if statement needs a little discussion. Remember, an if body is executed if the condition is true. Since Boolean values are stored in the is covered array, is covered indexed by I will return either true or false. And since the program wants to know if all the numbers are covered, if a false is returned from the array, it needs to be turned into a true condition. Hence, not is covered indexed by I. And if the body is executed as soon as one false is encountered, there's no need to continue through the loop. Therefore, the break statement. So your problem is to build a deck of cards and then randomly pick 4 cards from the deck. Well, the code on the left simply initializes our deck. Initializes it with values from 0 to 51. We have 52 cards in the deck of cards. The code on the right then shuffles our deck. We've seen this code before. So between the two, now we have a deck of cards that have been shuffled. A deck of cards doesn't simply contain the numbers 0 through 51. We kind of need 2 additional arrays. One for suit, called suits, and one for rank, called ranks. Now a random number is generated between 0 and 51 to pick a card out of our deck. And if the generated index is divided by 4, well, the result will be 0 through 3, which will be used to index our suits array. And if the value of the indexed element, all right, is modded, the remainder operation, with 13, its value will be 0 through 12. And that can be used as an index into our ranks array. The next slide gives some visualization of this setup. I think this visual gives a pretty good idea of what's going on. Conceptually, the deck is divided into 4 suits of 13 elements each. Our deck is initially loaded with the values 0 through 51, and then it's shuffled. Now suppose that our random index generator results in a value of 39. Well, 39 divided by 13 is 3. Consequently, the suit is clubs. And the value of our 39th element is 50. And so 50, mod or remainder, 13 is 11. Therefore, the card is a queen. The result is the queen of clubs. Try it for yourself. Well, all the programs in this chapter can be found using the link found under Content on Blackboard. Too bad we won't get as far as Chapter 25, where we can redo this problem and graphically draw the cards that we randomly pick. Often in a program we need to duplicate an array or part of an array, and as such you may attempt to simply use the assignment operator. So we want to copy the contents of list 1 to be the contents of list 2. And as you can visually see, simply using the assignment operator, list 2 equal list 1, results only in list 2 pointing to the list 1 array. We have not copied the contents, and in fact, list 2 has become orphaned and is considered garbage. So here's another example, a common mistake illustrated in the last slide. is we set target array equal to a source array, assuming that the values in the source array will be transferred to the target array. That was not the case. Remember, the array variable is not the array. It is the reference or an address to where the array exists. So consequently, the statement resulted in both variables referencing the same array. That is, what we copied was the source array's address. One way to copy the array is to use a for loop to copy one element at a time from source array to target array. Well, we're lucky that the system class has a copy array method. It's a void method. It does not return a value. And pay particular attention to the different parameters. Array copy from the source array starting at a particular element number, in our case 0, the target array and where it should start copying, and how many elements it should copy. So it's pretty flexible. Our little for loop didn't quite give us that flexibility without some real programming gyrations. Just a little snapshot of the API documentation for the arrays class. If you want to use this, note you have to import java.util.arrays. Just kind of showing some of the overloaded methods for copy, a little bit more flexible than maybe our for loop. And we'll be looking at many more of the arrays methods. Until next time then, when we'll finish up arrays, we'll cover a little bit more on the API arrays class and also cover passing arrays to methods.